so you start to catch on with the pattern. It's really a matter of using the pattern. Now, different lotteries have different rules. You'll have several different types of lotteries in your problems, your quizzes and stuff, so just make sure you read through them. Always think about how many numbers are drawn, how many do I need to match of those, and then how many other numbers are out there, of which, how many of those other numbers, those non-matching numbers can be on my ticket. Okay, so if we're looking at the total number of possible outcomes, how many white balls are in the hopper altogether? 59. How many could you select from? 5. So your total number of outcomes, you select the white ones, 59, choose 5, and you need to pick the Powerball. Well, there's 39 Powerballs altogether. You're going to select one of them. Now, if all of the possibilities were listed up here, were listed in your table, you could just add them together, but they're not all listed there. For example, you don't have the chance of getting just 2 numbers, and so on. So that's why I'm looking at this method. Your total number of possibilities is what? Okay, 195. Okay, so there's over 195 million possible tickets out there. Okay, so this is one of the reasons why when the jackpot gets big, companies don't just band together to say we're going to buy every possible number out there, because it would cost them over 195 million just to do that. Plus, then if the jackpot, if there's multiple winners, so the jackpot gets split anyhow, and the taxes, it's not advantageous for the company to do that. Okay, so if we're looking at the expected value, we're going to use these non-jackpot values over and over. So I'm just going to, if P is prizes other than jackpot, I'm going to kind of look at the frequency part of the prizes other than the jackpot. Since we're going to use that number multiple times, I think will save us some time in the long run if we do that. So there's 38 ways to win $200,000. And then there's 270 ways you could win $10,000. And then 10,260 ways you could win $100. And then so on your 14,310 ways to win $100 again. Lots of ways you can win $7. Okay, so again, all I'm doing is taking the frequency times the price, just like we did yesterday. Frequency times the price, the weight of it. Goes to we will when we do the expected value. I'm just trying to get this number because we're going to look at different scenarios. If the jackpot's this, what's the expected value? If the jackpot is this, what's the expected value? Well, the jackpot will change, but the non-jackpot prizes don't. Yeah. So if I have that number, then I can just use it multiple times. And I'm just going to put that in. There's more numbers there. You get the idea what the process is, right? So when you compute that, I believe you get 34,112,290. So if we did the P from above, 34,112,290. Now, this is one, if you're doing these problems with lots of computations, understand, if you want to explain what you're doing instead of writing it all down, that's fine. You just need to do one or the other. Either show it or briefly explain what you're doing. And just so you can see that you're understanding the concept. So the minimum jackpot was 20 million. So let's look at what the expected value is of this jackpot. So there's one way to win 20 million. The expected value we gained from all the non-jackpot prizes was the 34,112,290. And we're dividing it by all the tickets out there, 195,249,54. If you divide that out, you get just a little under 28 cents. Okay. So your expected value, if you play this lots of times, you could have expected to win 28 cents. Tickets cost how much? $1. At this time, they were $1. So if it's a $1 ticket and you get 28 cents back, every time you buy a ticket, how much are you donating? Or could you expect to donate? Right? The lottery system is taking in 72 cents, keeping it. That's their expected return. Okay, now the other thing with the lottery too, if you win prizes, what do you have to do with those prizes? Yeah, taxes. So
Is there a limit to how high, like if you just like over $100 and get the tax, or do you always have to tax?
There's a limit. There's a limit. I don't know what that limit is. It's, yeah, I don't think you're getting,
it's more into,
I don't think you're getting taxed on the $4 prize.
yeah, but I was more like $100.
That sounds about right. It's definitely, it's similar to, there's a gift tax law. If somebody gives you money, if somebody gives you $20, what's that?
You can give a gift of, I believe, up to $200,000 and it's not taxable.
Not that high.
No, because we learned in life skills that it's actually really high.
Yeah, but for after prom, when they were buying the gifts for after prom, they had to keep them under a certain amount so that they didn't have to pay gift tax.
Right.
So it had to be under $500.
Right, and it could vary, but the idea, there's limits. So, I mean, somebody gives you $20, yes, you're not reporting that. Somebody gives you a substantial amount of money, yes, you do report that. Largest prize ever won by anyone was $200,800,000. Okay, what was the expected value of this round? So the jackpot gets big. So we have the same idea, but now we have 200,800,000. Sorry, 34,290,000. That's the frequency times the prizes of all the non-jackpot. Okay, so this one, now the lottery system was basically looking at expecting to pay out what if states